Hope everyone is well. We're going to go through shortly 6.2 notes 2 coterminal angles. But first, I just wanted to go through and remind you of a few things, okay? Steps to fill out the unit circle. Label degrees starting with the positive x-axis representing 0. Okay. Count around the circle by 30 degrees and skip the middle 4 angles in each quadrant. So you would start here, this purple line with 0, then it would be 30, 60, 90, 120, 150, 180, so on and so forth. So the green color you will be skipping. Okay, so you first want to label 30 degrees, every 30 degrees, then label the 4 remaining, so 45, 135, 225, 315. Fill out the points on the X and Y axis. Fill out the points in the quadrant 1 using special right triangles. So you're filling out the coordinate points. Remember, it's a unit circle, so therefore the radius is 1 all the way around. That's why our hypotenuse is 1 for these 3 triangles, and we're able to use special rates to help us figure out the coordinate points, which we did last 2 classes ago. Okay, so for 30 degrees, it was root 3 over 2 and 1/2. For 45, root 2 over 2, root 2 over 2, and 60 is 1/2 and root 3 over 2. But looking at 0, that's 1, 0, and this is 0, 1. So you're able to fill out the whole entire unit circle using quadrant 1. Okay, so the appropriate signs, quadrant 1, everything is positive, x and y. Quadrant 2, your x values are negative, your y values are positive. Quadrant 3, they're both negative. Quadrant 4, your x is positive, your y is negative. One way to remember, all students take classes. This means what trig function is positive. So sine, cosine, and tangent are all positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third quadrant, and cosine is positive in the fourth quadrant. Okay, and you could check to see if all angles that have the same reference angle use the same point, with exceptions of sines. So the bow tie idea, as you see in the description above. These 4 values, 4 angles, represent 30 degrees. So this is 30, this is 150, this is 210, and this is 330, creating a bow tie. Meaning, if I was to draw perpendicular lines around the yellows, then I would create a bow tie. And that's how you complete your unit circle. Okay, that's how you complete your unit circle. You keep your reference angles all together. Okay, and also as a reminder that you have 30-degree angle here. Okay, you have a 30-degree angle here, 30-degree angle here, and 15 in between. So that's one way also to fill out the unit circle. And then with reference angles, you are using the closest x-axis, okay, the closest x-axis. So for example, what's the reference angle of 330? Well, we use 360. 360 minus 330 gives us 30 degrees. Okay, so we're going to try a few. State 3 angles that have a 20-degree reference angle. Okay, 20-degree reference angle. So in the second quadrant, you would take 180 minus 20 to get 160. In the third quadrant, you would take 180 plus 20 to get 200. And then in the fourth quadrant, you would take 360 minus 20 to get 340. So I want you to take a minute to pause the video and also try these 4 examples here. Okay, we should have gotten the following reference angles. So 182 is roughly in that ballpark for quadrant 3. So we take 182 minus 180 and our reference angle would be 2 degrees. For B, we take 220 minus 180 and we get 40 degrees. For 315, that's actually on the unit circle, so it's going to have the same color as I had, which was green. So you take 360 minus 315 and you get 45. 306 is also in the 4th quadrant, so you take 360 minus 306 and you get 54. 54 as a reference angle. Okay, so when you're drawing angles, there's 2 things that you have to remember. You have to remember you're starting with a positive x-axis, okay, which is right here where we start the unit circle at 0. This is called the initial side because it's your starting point. Then for a positive angle, you start moving in the counterclockwise direction as we do in the unit circle. For a negative angle, you do the opposite. You move in the clockwise direction, making a negative angle. Always show the direction you went with an arrow and draw a line to show the terminal side. So this is your initial side right here, and where you end is your terminal side. So I drew the following for you. For 220, you start here. 220 is in the 3rd quadrant, so it's roughly in this ballpark. So I drew this red line around to show the direction going counterclockwise. Now negative 30, you still start at that 0, create a 30-degree angle going clockwise. Okay. Now to show your angles, you have to have both of these arrows, the initial side as well as the terminal side, okay, with arrows because you're representing an angle. Negative 270 starts here and you're going clockwise to the top here. The what would have been, oops, excuse me, would have been positive 90 degrees. Now you see 405, well, that is greater than 360, so that means it completes one full rotation, so 360 degrees plus something additional, which would be what? Which would be 45 degrees. Now this is an example of a positive coterminal angle, meaning if I take 45 degrees and add 360, I have 405, which is a coterminal angle of 45 degrees. Okay, so we're going to get to coterminal angles pretty soon. I just want you to try these 3. Okay, negative 240, negative 180, and 161. So pause the video now, try 5, 6, and 7, and we'll check our answers. Okay, so we should have gotten the following. Okay, negative 240 going in the clockwise position. If you need to know where that lands, well, you take negative 240 plus 360 to get 120. So negative 240 is a negative coterminal angle of 120 degrees. Now negative 180, it's negative. We're going in a clockwise direction and we end up at 180. So negative 180 is a coterminal angle of 180. Now 161 falls within the unit circle. So again, I used red because we're going in the counterclockwise direction. It ends up in the 2nd quadrant. So some definitions for you. A coterminal angle is an angle that have a common terminal side, meaning where they end up. These angles end in the same location, therefore they have the same point, meaning their coordinates are exactly the same. The only difference is how many rotations around the unit circle it took to get there. Okay, so we're now looking at an example. 30 degrees and 390 are coterminal. So we're going to draw both angles, which I did below, then determine sine, cosine, and tangent for both 30 and 390. So 30 degrees falls on the unit circle. It's in the first quadrant. Okay. 390, if we take 390 minus 360, we end up getting 30 degrees. However, you're making one full rotation plus 30 degrees, and you're ending at the same point. So what is the coordinate for the point at 30? Well, looking at the unit circle and special rates, we have root 3 over 2 and 1/2. What is the coordinate point at 390? Oh, look at that. The same thing. Even though it made one complete rotation, you're still ending at the same spot. So your terminal side is ending at the same spot. So now we want to evaluate sine, cosine, and tangent for both. So pause the video and find the sine, cosine, and tangent for 30 degrees, as well as sine of 390, cosine 390, and tangent of 390. So hopefully you guys were able to fill out sine, cosine, and tangent. Okay, the sine of 30 degrees is your y value, so that's 1/2. Your cosine of 30 degrees is your x value, root 3 over 2. Your tangent is your y, so sine, over your x, cosine, so it's 1 over root 3. You cannot have a radical in the denominator, so you rationalize, and you end up getting root 3 over 3. Well, since 390 is a coterminal angle and you're ending at the same location, your values are going to be exactly the same. So to just reiterate what we needed to find a coterminal angles, you add or subtract a full rotation of 360 to the angle as many times as desired. So if you're given an angle of 50 degrees, find a coterminal positive angle. Well, I take 50 plus 360 and I get 410. 410 is a positive coterminal angle of 50 degrees. If I wanted to find a negative coterminal angle, I take 50 minus 360 and I have negative 310. Okay, so we're going to try these two together. Now this is already negative, so in order to find a positive coterminal angle, I add 360 and I end up getting 148. For negative 212, to find another negative coterminal angle, I subtract 360, get negative 572. Now say if I was given negative 600 as an example. I'll go to another screen. If I was given negative 600, well, to find a positive coterminal angle, I will keep adding 360 until it becomes positive. So if I add 360, I end up getting negative 240. Well, I'm looking for a positive coterminal angle, so I still have to keep adding 360 until I get to a positive angle, which is 120. So 120 is a positive coterminal angle of negative 600, meaning they're going to have the same exact coordinates as 120, which is negative 1/2 and root 3 over 2. Negative 240 is a negative coterminal angle of negative 600. Okay, negative 600, if I was to take negative 600 minus 360, I will have another negative coterminal angle of negative 960. Okay, so if you're given a negative coterminal angle, to find a positive coterminal angle, you add 360 until you're in a positive range. For another negative coterminal angle, you take a negative given to you and you subtract 360. Oh, this is 960. Sorry about that. Okay, so that's how you find the positive and negative coterminal angles. So I want you to try the practice on coterminal angles, reference angles, and the unit circle to evaluate without a calculator. So try these 6 problems, I believe, A through, oh, they're labeled again, A, B, and C, and then A, B, and C as well. Okay, do those 6 problems, so pause the video and then check your answers before we begin the next part. All right, so the answer to the practice is below. Okay, so the sign of 225, that's actually on the unit circle. So 225 is in quadrant 3. Sign is going to be positive because both sine and cosine are negative there. Sorry, it should be negative, which I have highlighted. Quadrant 3, sine and cosine are both negative. The reference angle is 45 degrees. Now it says one coterminal angle. I gave you either positive or negative. I gave you both. On our tests and quizzes, it will be telling you if it's a positive coterminal angle or a negative coterminal angle. So I gave you both there. Positive, I added 360. Negative, I subtracted 360. For B, cosine of 405. Okay, that's in the first quadrant because if I take 405 minus 360, I actually get 45 degrees, which is the reference angle. And the cosine is the x value, and it will be positive, so root 2 over 2. And here are the 2 coterminal angles. Tangent of 315 is in the fourth quadrant. That's also on the unit circle. And it's going to be negative because your y is negative, so negative over positive makes it a negative. The reference angle is 45, and it ends up being -1, the tangent of 315. Because you have negative root 2 over 2 over positive root 2 over 2. The same number over itself, and because it's negative, gives you -1. So I listed for you positive coterminal angle and a negative coterminal angle. Then the last 3 are below. Okay, so hopefully you were able to find the exact values, which are written in the pen here in black, and then the quadrants they begin in, that they end in actually, and should the answer be positive or negative, plus the reference angle. Okay, and again, you use the x-axis, either 180 or 360. Positive coterminal, you're adding 360. Negative coterminal, you are subtracting 360. Okay, so that should give you an idea of how to find coterminal angles using your reference angles, finding exact values. Okay, the next point here is probably another refresher for you guys when you are given a point on the terminal side, so where it ends. So this blue dot here was 8, -6. But if you notice, I drew the triangle, drew the point first, then I drew the point by going right and then down. Okay, then I drew the hypotenuse as well. We're trying to find the length of the hypotenuse because we're given the x value and the y value. Now, since I knew this was in the fourth quadrant, I knew it was in the fourth quadrant because my x is positive and my y is negative. So to find the hypotenuse, we use Pythagorean theorem. A squared plus b squared equals c squared to find your missing side length. In this case, we're trying to find c squared. So to find this, we have a squared, which is 8 or -6, whatever one you want to use first. 8 squared, 64, plus -6 squared is 36. 64 plus 36 equals 100. You take the square root of 100, your missing side length is 10. So now you set up your trig ratios. Sine is, remember, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And again, you want to reduce these at the end. So for sine, here's our angle, and it's always from the origin. Opposite, -6 over 10, which reduces to negative 3/5. Cosine adjacent over hypotenuse, so 8, this should be positive 8 over 10. Okay, positive 8 over 10 because cosine is positive in the fourth quadrant. So this should be positive. Let me just make that positive for you so we don't get confused. This is positive. Okay, so therefore my reduced value, hopefully, is going to be positive. And I just copied it over. That's why there's a negative still there. And once we reduce, it's positive 4/5. Now tangent is opposite over adjacent. So negative 6 over 8, okay, which reduces to negative 3/4. So that's how you find exact values when you're given a point on the terminal side of angle theta, which we don't know what the degrees is, so we create our own triangle here to find the hypotenuse. Okay, so I want you to try example 2. Let the point -2, -1 be on the terminal side of the angle theta. Find the exact value of the trig functions. So -2, -1 would be in what quadrant? They're both negative, so -2, -1 would be in quadrant 3. So go ahead and draw your triangle, okay, find your hypotenuse, then calculate your trig ratios. So pause the video and we'll check the answers shortly. Okay, so you should have gotten the following for your hypotenuse. You should have got plus or minus √5. Now our hypotenuse is always positive, so we're going to use the positive √5 because when we get that, -2 squared is 4, -1 squared is 1, 4 plus 1 is 5. Take the square root of 5, you get plus or minus √5. But again, it's always positive, so you have √5. And your angle is always from the origin. So to find sine, it's opposite over hypotenuse. So -1 over √5. You cannot have a radical in the denominator. So you take the square root of 5, top and bottom, and you end up with -√5 over 5 as your sine value. Cosine adjacent over hypotenuse, so you have to do the same thing. Here you end up getting -2 √5 over 5. Tangent is opposite over adjacent, so you have -1 over -2, which ends up equaling positive 1 over 2 because tangent is positive in quadrant 3. So we went through a refresh on reference angles, drawing angles, also finding coterminal angles and drawing those angles as well, and finding exact values. And also, you're given a point on the terminal side, you want to find exact values of trig functions. So that completes 6.2, notes 2. What I want you to do before you finish watching the video is complete the practice below, check your answers on Google Classroom, and make sure you write down any questions that you may have regarding 6.2 because we will go over them next class. If you have any questions, please send me an email and we could set up a Google Meet or for like an extra help session, whatever you guys choose to do. So again, good luck and I hope you have a good day. And if you have any questions, please let me know. Thank you.